cosa solamente che è ancora aperta con le mie credenziali, quindi lui non è come moderatore, ma dovrebbe chiudere. Sì. Reza, can you hear me? And the issue is that now you are not the moderator, so you should maybe reopen this room.
Yes, I think that a previous moderator named Alfonso should left this room, and then I could take the role of moderator.
Yes, it's me. I left it open.
Okay, thank you.
I close it, and you reopen it, okay?
Okay, I will restart it. Thanks.
Is here, no? Start the camera.
The camera.
Yeah, connecting.
Okay.
And now.
Yeah.
Okay.
Entire screen.
Entire screen or entire screen? Yeah. I think it's the entire screen.
Però tienes que abrir la aplicación, ¿no?
Yeah. Okay.
Pregúntale si lo ven.
Do you see the screen?
Sì. Però vediamo la modalità di presentazione.
Maybe the microphone is not.
We see it, but the presentation mode.
Yeah, so it's the wrong screen.
Yeah.
Should change.
What? ¿Tengo que cambiar algo aquí?
Prueba condividere la finestra invece che.
Perché secondo me non c'è duplicato del display.
Io credo che sia aspetta.
Non sta duplicato, c'è il display.
Display mirror.
Tu sei collegato.
Duplicate or swap presenter view and the slideshow or duplicate. Duplicate.
Okay.
It's okay now?
Yes.
Okay. But we have no feeling from the. So you can see it and you can hear it. Yeah, I'm talking. Yeah, okay, perfect. Well, good afternoon. Welcome everybody to the workshop on theoretical chemistry and computational modeling and applications. We have 5 interesting talks in this workshop. I hope it will generate an interesting debate also. And the first speaker is Noelia Faginas Lago she's an associate professor in the University of Perugia, and she's going to present the work, a computational analysis of the DMSO water interaction toward implementation of an accurate force field. Noelia, your turn.
Okay. Thank you, Marcos. Thank you for this, to give me the opportunity to present this work. So this is a preliminary work to start a research line about this system. Here we will see a computational analysis of the DMSO water, dimethyl sulfosido water interaction. So toward the implementation of accurate force field. in our research group, an important part of our research is to develop the new force field to run the molecular dynamics. I am speaking about classical molecular dynamics. I am from University of Perugia, Department of Chemical, Chemistry, Biology and Biotechnology of the University of Perugia in Italy. Okay, why study the DMSO? The DMSO is the dimethyl sulfoxide. It's bright in the literature. If you put in Google, DMSO is the acronym, is recognized, and that is is very, very disturbing me that is not correct, right? That the three is okay, but it's changing from the keynote to PowerPoint. CH3SO CH3. In the first view, you can see that this molecule will have two methyl groups. Okay, so why we have decided to study this type of molecule? We have started to decide this type of molecule because it's a key species in medicinal chemistry and biology, where it shows a strong pharmacological potential. During the COVID moment was very important. The possibility to use the DMSO like due the behavior of the stream drop in the freezing point of solutions. What it means that this temperature is fall very, very decrease in water, and it allows that, for example, the virus, some proteins, and some any biological molecules can be stay inside without lost the particular properties. So you know that, for example, the proteins, when they reach a determined temperature, these proteins lost some characteristics. In this case, was observed that the dimethyl sulfoxide give like a cave, so maintaining the properties inside of the membranes and so on. Okay, like is that is called like a cryoconserved cells, increasing this possibility that survive this type of molecules. And that is the first thing that occur with experimental group in our university, that they study this type of systems with the spectroscopy, and they ask us about the some molecular dynamics calculations. Okay, so it is here is shown some literature review about the dimethyl sulfoxide. The dimethyl sulfoxide, how you can see, there is the cellular cryobiology, thermodynamic and mechanical effects. Is an important cryoprotector used for the preservation of biological samples, for example, in extreme conditions. So the hydration, low temperature, and if you look in the literature, there are not enough, there is someone, but not a lot, of studies of classical molecular dynamics. There are, but these studies that in this case using the amber force field. But why? So in the sense, it's not wrong use amber force field, but we have observed that in some cases that we will see the hydrogen bonding are not represented or described in a good way with the parameters that obtained by the amber force field. Another thing is that this, for example, in this work that we have read and studied a lot, the parameters obtained for the amber force field are very, very old, so are not obtained from ab initio data or for this particular molecule, are obtained, extrapolated for the other molecules, okay? So we need to give an idea that it's possible to create a new force field for these interactions, and that is the idea of this presentation, okay? So far we have seen using the theoretical methods, obviously firstly the electronic structure calculations using Gaussian, Orca, and so on. In our case, in our group, my colleague used Gaussian to optimize that, we will see later. And, oh, I'm sorry. Okay, so the second step is define the potential energy surface to describe the intermolecular interaction. That is the business that interests us. Again, the geometry optimization to obtain the new parameters of the better parameters that the literature provides us, and run the molecular dynamic simulations. Okay, so first of all, my colleague did the optimization of the two molecules separately. You know that to start initial geometry, optimize the DMSO and the water. Okay, these molecules were optimized separately with the DFT level using Vitré-Lippe functional with the correlation, okay? And obviously you know that after that evaluate the harmonic vibrational frequency calculations, and then this geometry optimized were used to evaluate the electrostatic potential atomic charge. Because this is an important point, because in the literature, the amber force field or the another force field that you can find for this system are not given where or how were evaluated this atomic charge. You know that the atomic charge is a very important feature to evaluate the intermolecular interaction, to evaluate the total interaction. Okay, so to evaluate, in order to evaluate the electrostatic potential atomic charge, we have used the Vitré-Lippe functional with 4 different basis sets. So starting with the Poppel basis set and 4 plus different correlation, consistent, valence, polarized. That is, that is the normal that you can know. These calculations were did with Gaussian. So the idea, the second step, we have optimized our 2 molecules, the DMSO and the water. So the idea is we want to evaluate the intermolecular interaction. You know that the total potential interaction between the molecules are given as a function of the distance of these molecules. And it is given as a split in a non-electrostatic contribution and an electrostatic contribution. The electrostatic contribution will be evaluated using the Bloch's law, that for it we need an accurate charge, okay? And they are necessary for our implementation in the classical molecular dynamics. And our improve, where we improve here in the intermolecular interaction. This is the part that non-electrostatic is the intermolecular interaction that normally is called van der Waals interaction, and we wanted to study what happened or improve what happened at a long range distance. So because this contributed to the interaction. So we want to define an intermolecular interaction taking account the strength of induced dipoles attraction and the average molecular size repulsion. That is the improved respect of the classical intermolecular interaction that you can use, and obviously use the force field that we have found in literature. Okay, so At this point, I would like to introduce the improved Lennard-Jones model. The improved Lennard-Jones model is a model to evaluate the van der Waals interaction developed in our department, in our group. Here, there is the most perspective about the beyond the Lennard-Jones model as simple and accurate potential function proved by high resolution scattering data useful for molecular dynamic simulation. If you observe, that is the formula used for the improved Lennard-Jones. Is in a determined way, is like the Lennard-Jones. For this reason, is called improved Lennard-Jones. Here we have represented for the academic purpose the classical intermolecular interaction. Okay, so here we wanted to evidence where is the parts that are not good defined with the classical Lennard-Jones. Obviously, normally I speak about classical Lennard-Jones because the formulation will remember to the Lennard-Jones, but it's in the same if you use another type of potential. Okay. This type of potential is given, you can observe that in this potential we need 3 parameters. The first parameter is the epsilon, that is this, is the well depth of the minimum at the minimum distance, so at the equilibrium. So like in the Lennard-Jones. And in this case, Rm is the distance where you can find this geometry optimized. So in this point, okay. And so far it's like of this point. Here you can see that you have an exponential part. This part m is a value, is a constant value that can be a value of 6 if you are evaluating the interaction between a neutral interactions, and or 4 if you are evaluating an ion neutral interactions. And it you can observe how is developed as take care about the single polarizabilities of the atoms that formed the interacting centers between these interactions. And it gives that the possibility to take care about the induced dipole attractions and take care about the average molecular size repulsions. Okay, so if you observe here the parameter, different parameter respect to Lennard-Jones potential is this beta. This is exponential parameter. In the classical you have a 12.6. Here you have this expression, and that is given by this beta. This beta is a parameter that gives a physical idea about the environment of the interaction of these molecules. So it means that this beta oscillates in an interval between 6 and 8.5. In this beta, you can try, but this beta is depending about the polarizabilities, and an important thing is that you know that the atomic polarizability needs to give the total polarized of your molecule. So you can vary the value of beta to try to define better all of this part. So the attractive part respect of the classical Lennard-Jones. Okay, you can see that here is given by, for example, epsilon is given by a constant value. This constant value is obtained from the experimental results, because the important thing of this potential is that we're born from the cross-big experimental results for some systems. At this point, you obtain this value, and you need to obtain the C 6 effective respect of Rm. You see that this Rm is given as a function of the different polarizabilities. Here I would like that to observe that this part of this potential is in the literature that give the difference here and here respect of for the same system with the classical Lennard-Jones. Okay, so far the idea is use this type of potential for the dimethyl sulfoside water interaction. So at this point we have optimized the initial structure with Gaussian. Okay, we have the geometry optimization, and here are given the structure details of the two molecules. Okay, you can see that in this molecule, I would like that to observe that here we give in black are the distance, in blue are the angles, and you observe that we consider the H atoms of each methyl moiety in the same way, but we consider the methyl like an interacting center, not each H and each. We consider that the interacting is the point over the carbon atoms, in this case in the methyl group. So we consider in the dimethyl sulfoside the methyl group, the sulfur, oxygen, and another methyl group. And here we consider that we have the oxygen and is given by the HW to difference of the hydrogens of the other molecules. Okay. We have seen that for doing it, we have used the Vitrelip out CCPVT zeta level of theory because we have observed that we have optimized using this basis set, and we compare with the NIST. With the NIST is the data bank of the crystallography, and compare. If you observe, obviously is not the same, but is small different. The most different value is given by in this situation for this distance, the carbon sulfur distance. We have obtained also the angles, and we can consider that this basis set and this level of theory give us a good balance between computational cost and accuracy. This is the first test. Okay, so at this point, we decide to evaluate the atomic charge analysis because for us it's very important to do the electrostatic potential atomic charge. Okay, here we evaluate it in atomic units for the water and for the DMSO molecules at different levels of the theory. See text for the details is inside of the paper. Okay, take care about this difference. You can observe that are not for each atom we obtained the same charge, were considered the hydrogens, the carbon, sulfur, oxygen, and the oxygen and hydrogen for the water. We obtained some different charges. You can see that in this case, for example, is different. Okay. First of all, to go on, we have evaluated, used these values of the different atomic charges to analyze the contribution of the dipole moment, and here must be written the polarizability. I don't know where it is. And here you can observe that here is the dipole molecule, dipole moment, and the polarizability for the dimethyl sulfoside and for the water were the different set of the basis set. At this point, we can decide we have decided that we obtained and we use for our calculations this set of values because compensate the computational cost and respect of the accuracy. Another way we have evaluated and compared with the list. Obviously, it gives us an idea about the importance of the atomic charge used in our calculations and how can vary the polarizability and the dipole moment. Okay, so we can play with these three values to obtain these different results. Okay, so we decided that we go on with this type of the high level of the theory. Okay, so at this point we want to decide to do the preliminary force field. In the preliminary force field, we have obtained that first of all, that is the distance and the angles that we have optimized, and that is the charge that we have decided to use. So that is the final parameters that we will use in a future to run the molecular dynamics simulations. Okay, at this level of theory. Okay, so here I would like to show you that is some final result that we have observed that in the case of the dimethyl sulfosido with one molecule of water, we obtained that the distance that obtained for the hydrogen bonding is given like 1.846 angstrom, and this is the angle. We can observe, and it gives an idea that we are in the good way, that when we increase add more molecules of water, we can observe that the distance increase because it gives the idea that the format of cave around of the DMSO from the water, and instead the angle is decreased. So that is the first result that we have used. Okay, here I would like to put that using this potential, intermolecular potential, that is the values that we have obtained using the charge optimized with the Gaussian and so on at the level, theory level that we have set. And we have obtained that is the list of parameters that we use for the definition of this interaction. So obviously we need here, there is one DMSO, sorry because it's not very good, one water. We have the interaction between water, the oxygen, the center of the interacting of the water is put over the oxygen, the water with the sulfur, the oxygen of the water with the oxygen of the dimethyl sulfosido, the oxygen of the water with the carbon, oxygen, carbon, and when you have more than one molecule of water, you have also the interacting of oxygen, water. So our water molecule has one interacting set. Okay, and that is the values of epsilon, Rm, and the values of beta. Obviously, these values were chosen in the way that we obtained that our molecules maintain the final polarity, the dipole moment. Okay, here I would like to show you some screenshot for the first molecular dynamics simulations. So today I don't present any result molecular dynamics simulations because the talk is for the interaction molecular force field. The idea is that we started with 1, 2, 3 to arrive to the limited number to obtain this curve around the 1 DMSO, and to arrive to introduce, more, so arrive to introduce more DMSO and more water. So the idea is to arrive at running a classical molecular dynamics to obtain the density, the radial distribution function, for example, how in this case. So 80 to 100, 240. So we have seen that the preliminary calculations said that at a short distance are in equilibrium 1 DMSO for 3 molecules of water. This is the relationship between these 2 molecules. Okay, so that is the last slide. That here I would like to put some values of the different parameters, the waters and the distance of the hydrogen bonding. Okay, so I have ended, and I would like to conclude that this type of potential gives us the opportunity to explain this situation of the DMSO inside of the water, and what we obtained that the relationship between the dimethyl sulfoxide in the water is 1 respect 3, how is in the literature and respect of the spectroscopy results. Okay.
Okay.
Finish.
Thank you, Noelia. Now we have a few minutes for discussion. Questions, comments? Yeah, Marcos.
Thank you very much for the presentation. As you have data from DFT calculations, have you considered using machine learning force field?
Machine learning
force field?
This is for the future. It's our idea. Our idea is like to use the machine learning force field for this type of interaction.
So in this case, we can combine efficiency and also high accuracy.
I think so, yes. In this case, I think so is not very clear how this interaction works. But I think that is a good idea. Use the machine learning force field for this type of intermolecular interactions.
Okay, you have a question? No, I have a few questions.
Okay.
I have three questions.
Okay.
Okay. So the first one is about the improved Lennard-Jones.
Okay.
Can you go to the slide? Okay. I'm curious about this coefficients or parameters,
Yes,
0.72, and
yes.
how are they obtained?
Are obtained from the experimental results that they did with the novel gases.
Okay.
So in a series of studies, it's from the experimental.
For experimental, not from
Yes.
high-level quantum mechanics.
No. This is for experimental.
Okay. And I have a question about the polarizabilities you use.
Mm-hmm.
You use polarizabilities, molecular polarizabilities, only polarizability for the molecules or for the atoms?
For the atoms.
Yeah. And what atomic model you use for that? I mean, you can use polarizabilities obtained from Mulliken, for example, partition, or atoms in molecules, quantum theory atoms in molecules.
But
or,
to evaluate these values.
no, in your I mean in your work with dimethyl sulfoxide and water.
Oh,
But
okay.
these are the molecular polarizabilities,
Yes,
I think.
Mulliken, I think.
Mulliken.
Yes.
Okay.
Yes.
And about the polarizabilities, these are calculated with B3-lib.
B3-lib with this, B3-lib with these different basis set, not I see Luca because
He did the calculations.
Yes,
He did the calculations.
yes.
And not did you try a benchmark with other functionals, for example? Because I think for polarizabilities, B-Philip can be good, or in some cases, it may be problematic.
Yeah, we were thinking about this at the beginning, but we saw that in this case, also because we check with Denise and with the experimental value. So once we have our polarizability, we do a spot check before evaluating the parameters. So in this case, it seems, but it can be also.
Yeah, the molecular polarizabilities are with a large basis set are okay. In good agreement with experiments. So. Yeah, and I have a last question about the parameters, the intermolecular parameters, also using B-Philip. Did you include a empirical dispersion correction? Yes. It's not.
It's not clear.
You have to include it. With B-Philip, you know that dispersion with B-Philip is not good. Okay. Thank you.
Okay. Thank you.
Let's clap the speaker. Okay. Second chair. Yes. No, this is my box. This presentation. Yeah. We have two Marcos today.
Si vede in modo presentazione. Quindi display setting. Adesso.
Stop it.
It's okay.
Well, it's supposed to move this. It doesn't matter. It doesn't matter. It doesn't matter.
No,
It's moving.
Okay. It's my pleasure to introduce to you Professor Marcos Mandado from the Universidad de Vigo in Spain, Galicia. And his contribution is about this software EDA-NCI, scientific software to investigate non-covalent interaction combining classical dynamic simulations and QMMM calculations.
Okay. Thank you. Thank you for the introduction. No, I think I speak loud enough. It's not necessarily the microphone. Well, good afternoon, everybody. So in this talk, I'm going to present a computational methodology to study intermolecular interactions involved in biological processes by combination of classical dynamic simulations and energy composition analysis based on quantum mechanics, molecular mechanics, hybrid methods. I will show you give you some details about the implementation, and then I will finish with a brief example of application. Well, among the different kind of intermolecular interactions we know, I will focus on those of non-covalent character. These are interactions between closed cell molecules or molecular fragments that don't provoke a chemical transformation, but they can play a very important role in many physical-chemical processes. Most of them are, this is the pointer here.
Sí,
This one. Okay. Most of them are included in this list, but in general, they influence these non-covalent interactions, any process taking place in a condensed phase. These non-covalent interactions can be classified according to different criteria. For example, if we consider the physical rigid, we can talk of classical interactions where we include the electrostatic interactions and inductive interactions here. And also quantum interactions with a quantum origin, where we have here dispersion, intermolecular electron exchange, spin repulsion, and even some kind of fragmentation, composition and composition analysis, We also can include here charge transfer interactions. But these charge transfer interactions are a kind of inductive interaction. So I leave it here, but in our scheme, we don't calculate charge transfer. Okay. Well, obviously, this the intermolecular interaction of quantum origin can be roughly represented using a classical model or a classical potential, especially the intermolecular electron exchange and the spin repulsion, which are both included in what we know as Pauli repulsion. Well, this is because I'm sorry for this background. This background, you can see very well. I'm sorry.
You can switch off lights, maybe.
Yes, maybe better. Better.
Okay. Okay. Thank you.
Maybe it's too much.
For your assistance. Okay.
You can proceed. Just fashion.
Ik heb aan dat net nog Well, well, I was saying that this is because the Pauli repulsion arises from the overlapping between electron densities of closed cell molecules. Okay, this overlapping of electrons comes with electron density depression in the intermolecular area. Okay, this is because of the very well-known Pauli's closure principle. In this two example, the water dimer and the interaction of pyridine with a graphene surface, we can see this electron density depression in gel. Okay, and also we have an electron density accumulation in the molecules. This is the spin repulsion. Okay, at the same time, due to this overlapping, we have an intermolecular electron exchange. Okay, between same spin electrons. The electron density deflection and the intermolecular electron exchange increase and decrease respectively the energy of the complex, but the net effect, the global effect, is repulsive. So the Pauli repulsion energy is positive. So this is why we call Pauli repulsion. Okay, this Pauli repulsion energy doesn't follow a simple analytical expression. Okay, so it can be roughly represented by a classical potential like the Lennard-Jones potential. Notice that I have said Lennard-Jones potential, not improved Lennard-Jones potential. Okay? So, even for the simplest example of interaction between two closed cell atoms, in this case the interaction between two atoms, okay, the Lennard-Jones potential doesn't work properly. Okay. On the right, we have the representation of the energy pools for the total interaction energy, okay, and the repulsive and attractive energies obtained from high-level quantum chemical calculations, in this case, coupled clusters with single, doubles, and triple excitations, and with a triple set basis set, okay, and those obtained with the Lennard-Jones potential. As we can observe, the well of the potential, the total interaction, the total potential, is well represented by the Lennard-Jones potential. However, the repulsive and attractive terms are largely overestimated. So we can conclude that the accuracy of the Lennard-Jones potential arises from a cancellation of these two errors. And relying on error cancellation in a more complex, in this kind of interaction in more complex systems, like biological systems, can be risky. So, in order to properly account for these quantum interactions, particularly the Pauli repulsion energy, we need to use, or we should use, okay, methods based on quantum mechanics. In addition, if we want to introduce the thermal effects, so investigate the molecular interaction at finite temperature, we need to run dynamic simulations. So in this case, ab initio molecular dynamics, okay, where we calculate the energies with a quantum method. Okay. In the extensively employed Bohr-Oppenheimer molecular dynamics, the dynamics of the nuclei are followed classically, but the energies are obtained at every point along the trajectory quantum mechanically. So we can perform a negative decomposition analysis based on quantum mechanics at each point of the trajectory and investigate how the intermolecular interactions changes, okay, along the trajectory, and how perform also the statistical study at a finite temperature of these interactions. Okay, this is what we are going to we try to do. Well, but as you know, the affinity molecular dynamic simulations are very expensive computationally, and in case of biological systems, they are unaffordable. Okay? We cannot apply this. So this is an example that illustrates this problem. Okay, this is the interaction of a molecular tweezer with the bromide anion. The bromide anion is inside the cavity. It's stabilized inside the cavity. Okay, these are the intermolecular interaction energy terms, the total interaction energy, electrostatic, Pauli, induction, and dispersion. Okay, obtained at equilibrium geometry. As you can see, the complex is highly stabilized, this energy, because of the synergy between large electrostatic and dispersion interactions. In order to investigate the stability of this complex at a finite temperature, okay, we run a Oppenheimer molecular dynamic simulation for a simulation time of 11 picoseconds, okay, using a simulation time of 0.5 femtoseconds. This entails a total of 22,000 quantum mechanical calculations that were done using a DFT functional, okay, and a double set, basis set. So this entailed more than 3,000 basic functions. We can infer from this large number of quantum chemical calculations with this large number of basic functions for each calculation that the time spent in the whole simulation was huge, just to cover a very short simulation time of 11 picoseconds. And for a medium-sized system, okay, for a medium-sized system, that is certainly insufficient to investigate a large biological system like a protein, for example. So, to follow a protocol accurate and computationally efficient to investigate the molecular interactions in large biological systems, we need to use hybrid quantum mechanics, molecular mechanics methods. Okay, as you probably know, in QMMM methods, we divide the system in at least two regions: the target region, described quantum mechanically, and the environment of the quantum region, which is described with a classical electrostatic or polarizable medium. Okay, we can, in addition to account for boundary effects, introduce a periodic one-year condition for a boundary potential. Well, however, even that we can deal with systems of thousands of atoms using QMMM methods, they don't allow running long dynamic simulations of hundreds of nanoseconds or even microseconds that we need to follow biological processes in a protein. We need at least a dynamic simulation of hundreds of nanoseconds. Okay, and in addition, it may introduce spatial and temporal discontinuities in the interface between the quantum and the classical region. This is a very well-known problem of QMMM dynamic simulations. So we propose a recipe, a protocol that follows these 4 steps to investigate finite temperature, to investigate intermolecular interactions along a trajectory, in a biological process. So first, we obtain the full trajectory using a classical molecular dynamic simulations in order to characterize singular points of the free energy profile. I mean, minima and maxima. Okay. So we select X-space geometries around these singular points, singular regions. Okay. To perform static, dynamic, quantum mechanics, molecular mechanics calculations on these geometries, and then to perform a statistical analysis of the intermolecular interactions using these geometries with an energy decomposition analysis based on quantum mechanics and molecular mechanics. Well, let me introduce briefly the energy decomposition analysis we have employed in our calculations. This energy decomposition analysis is based on the fragmentation of the one electron density and the exchange correlation density into components from the isolated molecular fragments or molecules, these ones, these two, and these two terms here, and those arising from the Pauli interaction and depolarization interaction. In polarization, we include induction and dispersion. Okay, in addition, we also split the nuclear potential into the fragment nuclear potential and the nuclear repulsion energy. These terms from the Hamiltonian, okay, into fragment, isolated fragment, and intermolecular terms. Okay, I'm not going to get into details because I don't have time, but expanding the total interaction energy expression obtained from the supermolecular approach, okay, we obtain, expanding it with this electron density and nuclear potential terms, we easily obtain the electrostatic, the spin repulsion, the intermolecular electron exchange, and the polarization energies. In addition, if we merge the spin repulsion exchange into the Pauli repulsion energy, as mentioned before, and apply second-order perturbation theory to depolarization energy to split it into induction and dispersion, we obtain the traditional decomposition of the interaction energy into electrostatic, Pauli, induction, and dispersion. Well, dispersion we also include terms of higher order than 2, which are normally negligible, but in strong interactions, they have important weight. Well, if we move to this is partition for a quantum mechanical calculation. If we move to quantum mechanics, molecular mechanics calculation, we have to include the effect of the classical potential into the different interaction energy terms. So, in the energy decomposition analysis, how to do that? The simplest way to do that is to include the potential created by the classical atoms in the MMM region into the potential of the nuclear potential corresponding to the fragment to which the classical region belongs to. In this example, the classical region belongs to the fragment B. Okay, we have the fragment A here, just treated quantum mechanically, and the fragment B treated classical, quantum mechanically and classically. This could be, for example, an ion here, and this could be the QMB and MMB, the water molecules surrounding the anion. And we are going to study the interaction between the anion and the water environment. Okay, so this classical potential may include just atomic charges for an electrostatic embedding, and also atomic induced dipoles for the case of a polarizable embedding. We have implemented both cases. Additionally, we have to include interaction of the classical atoms with the fragment A in the electrostatic and polarization energies. Okay, so an important question here is that many people do simulations of do a classical dynamic simulation, for example, and then just take a piece of the system, just analyze it quantum mechanically to investigate intermolecular interaction at quantum level. So, how important is to include the rest of the system classically, so to perform quantum mechanical, molecular mechanics, energy composition analysis, compared to quantum mechanical analysis, say, okay, so how is the difference? The difference is important or not? This is an illustrative example. This is the interaction of the ammonium cation with 100 molecules, 100 water molecules included in the quantum region. Okay, and then we compare this the interaction energy terms obtained this way with those obtained including also 2,900 water molecules in a classical region. As you can see, the difference is large in the electrostatic energy, around 40 kilocalories per mole of difference, and also it's significant in the polarization terms, the induction and the dispersion, around 4 kilocalories per mole, and it's negligible for the Pauli repulsion energy. This is expected because Pauli repulsion is what we call a short range interaction. So with the quantum region is enough. So conclusion, we have to include the classical region. Otherwise we are doing a very good calculation, very bad calculation, sorry. Well, this methodology has been implemented in the program, the software program called EDA NCI, which can be downloaded free of charge from the GitHub repository. Okay, so this program has an interface for Gaussian, for the quantum calculations, and with AMBER for the classical calculations through an interface. Okay, through an interface which is the interface was developed by colleagues from the Mobioken group from the Autonomous University of Madrid, and can also be downloaded from the GitHub repository. This package, Mobio2's package, brings the geometries from the AMBER calculations, generates input files for the Gaussian calculations. Gaussian calculates the electron densities employed by the EDA NCI program to obtain electrostatic induction dispersion Pauli energies. Okay, so we are now developing a more an advanced software within the project called BioELA. Okay, as the improvements and main improvements with respect to the EDA NCI is that we are developing a large interface with other software, electronic structure software packages, and also with other packages for classical molecular dynamics simulations. We include also the calculation of intermolecular interaction in the excited states, which is a delicate point, question. And also we include an automatic analysis of the optimal QM region in QM calculations. Another very important problem: how large must be the quantum region to get results that are convergent. Okay. And a model to perform statistical analysis of the results automatically, and also visualization of the polarization densities and the trajectories. I also included. Well, let me finish with a short example of application. The study of the penetration process of polychlorinated dioxins. You know that these are very toxic compounds. Through a cell membrane, and the subsequent interaction with the protein receptor AHR, which is thought to be strongly related with the toxicity of these compounds. Okay, so there are two studies. Yeah, 1 minute. Okay, so probably no many questions. Okay, so what we did, we have to do. What is the protocol to investigate this? So first, we ran the classical molecular dynamics simulation. In this case, using the umbrella sampling technique, okay, to characterize the minimum, the region where the free energy minimum is located. Okay, so to generate geometries within this region to perform the statistical study of the intermolecular interaction at QM and M level. Okay, but first we have to check the convergence of the QM region and the number of geometries necessary to get a convergent statistics. So when we perform it, we check this convergence. But we have found that all the interaction linear terms are convergent when the number of geometries included in the statistics is at least 40 geometries. Okay, only with 40 geometries we get convergent results, and also with a QM region including at least 11 residues. I'm not going to get into the definition of the residues here, but just to see that the QM region needs to be very, very large, because our simulation was the polychlorinated dioxin with a lipid bilayer including 128 DOPC lipid molecules. So in this case, each DOPC molecule is a residue. Okay, so it's a very large. Well, these are the results obtained for the average values for the intermolecular interaction energies. Okay, I'm not going to show you the statistical distribution of the different energies. It's also obtained, but these are the average results. Okay, so we can see that the interaction is mainly due to dispersion. Dispersion energy is this green bar. Okay, mainly because of dispersion, and then because of electrostatic interaction is important. Okay, we did the obtained for the interaction with the protein receptor. But in this case, we performed first a docking analysis to characterize the centers of the protein more susceptible to interact with the dioxins. Okay, but then we did the same characterization, classical mechanical simulation to characterize the minimum of the free energy. Okay, and then select as a number of X-based geometries in this region and perform an analysis of the number of geometries necessary to get converged results. These are the average results. Okay, but very similar to those obtained for the interaction with the membrane. And I'm finishing. Sorry for taking more time that I will stop in the beginning. So just to thank my colleagues involved in this project in the quantum chemistry group, and also the people from the MOBI-OKEN group, the group of Juan José Nogueira. We are strongly involved in this project, and also to the funding. Thank you.
Well, we are a bit late on the scheduling.
Sì.
So I'm sorry.
Okay. But just a quick question, if any.
Just a short question. Do you think machine learning could help in this kind of study or not?
We are now thinking of doing in the near future to use all this data obtained to include to train machine learning potential. So this is one of the ideas we have in mind.
Yes.
I don't know much about machine learning, but these people from this MOBI-OKEN group, they know.
Alex, I know about machine learning. It's not really straightforward. I'm not pretty much in touch with machine learning, but I know that there is not that simple. I know this since the electrostatic embedding. Yes, in QMMM, if you want to use machine learning also for these QMMM calculations.
I think that
It's not clear how to train with this with the electrostatic embedding. Maybe
But
it's not.
I don't know if I understand exactly what your question, but in this case, if you include this electrostatic embedding, it's just to get more reliable results to include them in the training. So, because you can see that if you want to use data obtained for this interaction between ammonium and water, and you do only quantum calculations, you have very different results if you improve your calculations with the classical reading. So, this what you can do normally. You include the formation, for example, of intermolecular interaction energies total. But for the moment, as far as I know, nobody did enlarge the data set with electrostatic, Pauli, so you get more, the information is more complete, I think.
Thank you, Marcus. There's a change. Next
Change again in
speaker
the-
is
I'm the chair again.
Borghesi.
Hi, everyone.
Hello.
Hi, ciao.
No, I think the next one is Marcos. Okay.
It's next.
Okay.
Yeah, sorry, I asked for a change because we're pretty late and I have a train to catch. So
Condividere
E deve condividere
Lei
lei.
capito solo
Aspetta.
su
Lei con
Chrome.
Ella tiene que ponerlo ella, claro.
Su Chrome. Aspetta, Costanza, che facciamo.
Compartir nosotros. Y comparte.
Come sa questa? Ok, Costanza, puoi
I think
condividere.
you can
Okay.
share your screen now.
Yes.
can you see me and hear me fine?
Yes.
Yeah.
Okay, you can see my screen, right?
Yes.
Yes.
Okay. So hi everyone, my name is Costanza, and
well, let me introduce you first.
okay, sorry.
Maybe. Okay, so the next speaker is Costanza Borghesi. Okay, she's a PhD student from the University of Perugia, and she's going to talk about DF2 plus U optical feature of thermochromic BO2, a power tool towards functional relative passive cooling implementation. So, Constanza, your turn.
Thank you. So yes, as I was saying, I'm Costanza, and today I will be presenting you some early results of a theoretical investigation that we are carrying out on vanadium oxide for relative passive cooling applications. So first of all, why are we interested in vanadium dioxide? Well, this is a material that is probably one of the most famous thermochromic materials, and this is a family of materials that it's characterized by a reversible change of color and optical properties caused by a temperature variation. And in the very case of vanadium dioxide, this is a phase transition that occurs at 68 degrees and involves two phases, a low temperature phase, which is called M1, then we will see why, and a high temperature phase, which is called R. So now let's see in detail some results about the structural properties of these two polymorphs. So the high temperature phase as a rutile symmetry, and is characterized by just one wave bond distance between the vanadium ions, which are placed on a, let's say, a straight line. According to our calculation, this distance is of 2.78 angstrom. While for the low temperature phase, this has a monoclinic symmetry and is characterized by actually two vanadium distances, which are not on a straight line anymore, but they are kind of tilting, so they follow a zigzag pattern, more say. And the shortest one is about 2.5 angstrom, and the other one is about 3.23 angstrom. So the structural change is also accompanied by electronic change. Also the electronic properties of the two polymorphs are actually different. So for the high temperature phase, we can find a metallic behavior where around Fermi energy, we can find contributions from partially filled d orbitals and pi star orbitals. While for the low temperature insulating phase, we can find, as I said, an insulating character. So we have now a band gap, which is caused by the splitting of the contribution in fully occupied lower D bands, and then we have full unoccupied pi star and D contribution. So this leads to the formation of a gap, which is around experimentally not 67 electron volts. Since the complexity of vanadium oxide has been really debated in the literature and is nowadays still debated, I would like to summarize now for you two main publications that have been considered now two stepping stones on the scientific history of these materials. So the first one was published by Goodenough in 1971, and where he basically explained this vanadium transition with caused by a structural change, which is called Pearl's distortion, that can be explained by the theory of the crystal fields, and is basically one single particle explanation. While soon after that, Francis Mott in 1975 argued that this transition can only be explained by taking into account the electronic correlation in vanadium dioxide. And this is also really important when we want to model this material, because we cannot use like standard methods like pure DFT, but we have to use extended method to the standard DFT like we did for the results that I actually just now showed you, where we have had to use the method DFT plus U to actually correctly capture the isolating character of the low polymorph of vanadium dioxide to actually obtain quite accurate gap. So now that we kind of saw what we are treating, more or less, let's move to the more interesting part, which are the optical properties of vanadium dioxide. Here I am showing you some results on the simulated optical properties, and from the optical conductivity, the absorption coefficient, and the reflectance of these two polymorphs. What I want to show you is that how different these two polymorphs behave when they interact with light. So we are interested in particular on the infrared, let's say, range. Then I will explain you why. And we can actually see from here that the monoclinic phase, so the low temperature phase, is transparent to the infrared light, while the rutile phase is highly reflective to it. And this is a very interesting property because it can be explained to maximize, and this is what we want to do, to maximize the efficiency on passive radiative cooling devices. What is the passive cooling phenomenon? This is a natural phenomenon that kind of allows a sky-facing object to cool without any extra energy input from outside and without any greenhouse gases emission, just by emitting thermal radiation, so infrared radiation, in the exploiting the atmospheric transparency window, which goes from 8 to 13 micrometers. Why is that possible? Well, it's possible because by emitting thermal radiation in this very specific wavelength range, the heat released can pass through the atmosphere and can be just released into the outer space, which is really, really cold at a temperature around 3 Kelvin. Usually a passive radiative cooling device is formed by two main layers. A first layer, which is highly reflective metal like silver or aluminum. And this basically just reflects mostly all the solar incoming radiation in the visible range. So this basically prevents the gain of excess of it from outside. And then we have the second layer, which is usually a dielectric material, which is capable of, it's actually the cooling layer, so the one who's responsible for the thermal emission of the radiation. And then on top of that, we would like to couple a thin layer of vanadium oxide to concentrate all the cooling power after the transition of the vanadium oxide into its rutile phase. This can work actually because the rutile phase is also highly reflective. So this also prevents the gain of the heat from outside and can help the radiative cooling process itself. So the problem is now that the temperature transition of vanadium dioxide is really high. Is too high to be exploited for room temperature, let's say, applications, because it happens at 68 degrees. We have to find a method to actually lower this temperature. And this method is, of course, doping, has been tried a lot experimentally. The problem now is that data are not, let's say, reproducible. So it's really, really difficult to work on vanadium dioxide on the doping of this material. So what we're trying to do now is that we are running some molecular dynamic simulations to actually not only understand the mechanism of this transition and try to reproduce the bare, let's say, structural transition and the temperature of it, but we are also trying to dope this material to kind of find a trend in dopants to see which one which ones can be inhibitors and which ones can be activators for the transition temperature of vanadium dioxide. So this was just a short presentation of what I'm doing now. I hope you enjoy it. I think this is all from me. And yeah, I think I'm done.
Okay, now it's time for discussions, questions, comments. No comments? No questions? No? Okay, so
Okay.
we're running out of time now. Maybe we can move to the next speaker. Okay, thank you, Constanza, for your interesting talk. Thank you very much.
Thank you. Thanks. Have a nice continuation. Bye.
Okay. Now we have to share again. No?
Yes.
The PDF. Yes.
Okay. The next speaker is Marcos Quiles. He's an associate professor from the University of Sao Paulo in Brazil. He's going to present the work Enhancing Low-Cost Molecular Property Prediction with Contrastive Learning on SMILES representations. Okay. Marcos.
Thank you very much, Marcos. I also would like to thank Andrea and Professor Wiley for organizing this workshop. I hope this workshop continues for a long time in ICCSA.
Hopefully.
And after a set of hard work, I will show you a very simple one. But it's a part of a larger project, which consists of several developments in the realm of machine learning and quantum chemistry, mixing both. So here's my agenda. I'll go fast. Close this. Okay. This project is part of a center called CINI, Center for Innovation in New Energies, which is funded by Shell Corporation and FAPESP, which is our state agency in São Paulo, state funding agency. We have several universities related to this project, and we have about 250 researchers among faculty members, postdocs, and also undergrad and graduate students. The first phase finished last year, and it took us a while to sign the contract for the second phase, but we are starting it right now. We have a window of 5 years to conduct this program. I'm with the Federal University of São Paulo University. And the mission of the center is to tackle energy transition challenge, generate knowledge, create capacities, and offer solutions. We have 4 divisions. Oh, it's not working. I think I'll run out of battery. No. It's that. Okay. I can continue. Okay. Just okay. It's okay. Sorry for the interruption. We have 4 divisions. 3 are experimental divisions. The first one is energy generation, mainly solar panels and wind turbines. The second is advanced energy storage, supercapacitors and batteries, the green energy production. And the 4th division is the computational material design division, which is composed mainly by 2 branches. One is atomic chemistry, and the other is machine learning. The PI of this division is Professor Juarez from the University of São Paulo in São Carlos, and I'm the co-PI and responsible for the machine learning part of this division. And we also, these divisions, one of their goals is to give support to the experimental divisions. We know that the design of materials, design of molecules is a very costly and very complex process. Maybe we can take months, even years to understand, to study experimentally on a specific project from synthesis to getting its properties. Even when using computational simulations, it can take a lot of time and a lot of cost, days or even weeks to simulate this project. And in this realm, I think machine learning can help a lot, AI in general. So given a molecule, we can train machine learning models to predict the properties, and also the opposite, using generative AI. It means given a desired set of properties, design new molecules. So yeah, it's a new trend topic that are being used currently to understand, to design materials, and to get properties of these materials. But to face this challenge, which is given a molecule, feed it to a machine learning model to get its properties, one fundamental step is how we represent this molecule in such a way that the machine learning model will understand what it is receiving. And we have several types of representations, text-based representations, graph-based representations. The geometry of the molecule can be used as well to feed the machine learning model. Here in this work, we adopt a very simple one, which is the smile. It's a string which represents the composition of the molecule. So we use this type of text to feed the machine learning model to predict the properties of this molecule. And interestingly, it's very suitable for machine learning language models, such as GPT, BART, and several others that we have in the literature. Contrastive learning, it's a new topic in machine learning. Basically, it's a self-supervised learning technique, and it learns representation by contrasting positive and negative samples. Basically, let's take this example in consideration. If you have two cats, we want to create representation of these two images that are very close together, very similar to each other. On the other hand, if you have samples that belong to different classes, different molecules, different images, like a cat and a dog, we want to create representations that are far apart as possible. So the main idea is to put together similar or positive pairs and push apart negative pairs. And the benefit, reduce the need of label data, which is quite costly to retain. We need, for example, if we have a molecule, and to analyze its properties, we need to run DFT calculations, for instance, to get its properties. And also enhance feature learning. For this study, we use 3 data sets, 2 public data sets. Needs a large one. We use it mainly for pre-training the model. We use about 1.3 million molecules with these features. We also use the QM9 dataset. It's a very widely used dataset as a benchmark. We use it to compare machine learning models. It composes about 133,000 molecules with the same features that we used to select the subset of the zinc. And besides the molecules, it has a representation, the SMILES representation, another string-based representation, and also the XYZ files optimized by DFT, and 15 molecular properties in this data set. And the third data set is ionic liquid molecules that was developed by the QT Nano group, also optimized by DFT. And in this data set, we have 2 properties, the HOMO and the LUMO. Here in this work, it's a bit hard to listen to, so it's okay. The positive pairs, we take 2 SMILES, different SMILES that represent the same molecule. The generation of these SMILES depends on the molecular graph. So it starts in a specific position, specific atom of the molecular graph, and then you start writing the SMILES that represent this graph. So if you change the initial condition of the graph, you have a different SMILES. So our positive pairs is, we have 2 SMILES that represent the same molecule. So the network knows that it's receiving the same molecule, so we try to approximate to get close together the representation of these 2 different SMILES because they represent the same molecule. On the other hand, the negative pair, we have 2 different molecules, 2 SMILES that represent 2 different molecules, 2 different types of molecules. In this case, caffeine and aspirin. So in this case, the model will try to create representations that put apart the embedding of these two molecules. Here's the general framework. We have, instead of 1 neural network, we have 2 neural networks. Each one of these neural networks receive one of those SMILES, which can be from the same molecule, permuted SMILES from the same molecule, or SMILES that belong to different molecules. So these two neural networks we try to represent, to learn these representations, and if we have a positive pair, these representations are maximized to become as close as possible. On the other hand, if you have a negative pair of samples, negative pair of smiles, we try to put apart these two representations. So by doing that, we learn a very nice representation that can be used to feed a predictive model to predict the properties. Some details, here in the encoder, we use two long short-term memory neural network, STM neural network. The tokenization process, we use the deep chain basic smiles tokenizer. And the loss function, we use the NT-X-Ent loss, and also the other optimizer to set up the parameters of this neural model. Once we have learned the representation for each molecule, which is represented here by Z, we feed the molecule here, extract the Z, and the Z feed a predictive layer. In this case, it's a multi-layer perceptron neural network that will reveal us the desired property of that molecule. It can be any kind of property if you have data to train this model. The experimental setup, I'm not going to give much details about that, but it's just saying how much neurons we used in each layer, how many layers, for reproducibility of this experiment. In the paper, we have all details about that. Here's some results. In the first scenario, we use the QM9 dataset. The first column is the baseline. We have a simple LSTM neural network which was trained by samples of the QM9. We get these bias and try to predict the property. The second column are the results using the contrastive approach proposed here, where we have two permutations of each molecule, two smiles that represent the same molecule, and we get one of these smiles. We will first train the contrastive model, and then we train the predictive model. And in the final, the third one, we train the contrastive-based model with two data sets, the zinc, which is the largest one, and the QM9 dataset. Interestingly, we had results a little bit better using just the QM9 dataset, and a little bit worse when you use the QM9 dataset and the zinc, which is a little bit awkward. We were expecting to have a better result here when using this large dataset for pretending the model. We're still trying to understand what happened here. In the second scenario, we use the ionic liquids dataset for property prediction, try to predict the HOMO in the loom properties. Here we use two scenarios, also the baseline with the long short-term memory neural network as a baseline, and then the contrastive model trained with the ionic liquids and the zinc dataset. Here we have quite similar results. We cannot get better results with statistical significance. But we are still trying to understand why our contrastive model were not able to improve the prediction of the properties as we were expecting. As some concluding remarks, we have here a very simple contrastive model that uses just the smiles as input, which is very interesting because we do not need to run optimization first to get the XYZ, to get the geometry of the molecule, to feed the machine learning model. We just need the composition. The permutation of the smiles that we feed in both branches reduce the need for canonization of the smiles, which is required in many machine learning models that use the smiles. Our initial results are sound, but we hope to improve it a lot in the future. In the next step, we want to use large data sets for the pre-training phase, and also, instead of using LSTM, use transformer models, which is the base of the ChatGPT, which is quite in the media right now. And for those who are interested in this kind of work, here you have another paper of the group, which instead of using smiles in the two brains, we feed the contrastive model with these smiles and also with a molecular graph. For this scenario, we indeed get very nice results, much better than those I presented to you in the former slides. Finally, I would like to thank my students, my collaborators, in particular Professor Juarez Silva from University of São Paulo and Professor Ronaldo Prato from Federal University of ABC. Here it's a picture of the whole division, the computational division. And if you want to, please visit us in Brazil and let's collaborate. And that's it. Thank you very much. And I'm open for questions if you have.
Okay, thank you, Marcos. It's time for a couple of questions. Questions, comments? And there?
Okay, it's contrastive learning. You in practice it is meant to recognize similar objects and different ones. It is only for this kind of so you can contrast many things. If it is, for example, if it is a stable molecule or a stable already, if it is the same molecule or not, if it is so I'm saying something correct.
Yeah.
So the property to contrast is up to you, in a sense.
We just need to get the positive and the negative pairs. And if you have, for
Or
example,
whatever.
whatever. It starts with image in the computational vision community, but now it's been applied in many scenarios.
Okay, and in your when you're showing these parallel layers, perceptual layers, and these are just standard layers, not convolution.
No, it depends on what kind of input you have here. For example, in this case that we have a graph and the smiles, here we have a language model, long short-term memory, and here we have a graph neural network. If you have images here, we have convolution neural networks. You can set up these branches of the model according to the type of data you have.
It's surprising that a simple representation can function in that way. So apparently just
The idea is trying to map a very high-dimensional problem into a lower-dimensional problem. And I have samples here in this Rn space, and I try to map this in our Rk space with lower dimension. So just get two samples that you know that two samples are the same, they represent the same kind of pattern. You try to map in this Rk that are close together. And if you know that the samples are different, you try to make this two representation apart. And luckily, this kind of learning paradigm is very useful, in particular when you have lots of unlabeled data.
Okay, thank you. No more questions. Okay, I have just, I don't know much about machine learning, but it's more a general question, maybe it's a new question. But machine learning was criticized in the beginning because of the loss of insight, chemical insight. Just give numbers, maybe good numbers, with good results, but the loss of the what chemists like that is explaining this property because of I don't know, reconjugation of things like that. A few days ago, I was in a conference, and a guy talked about machine learning and insight, getting insight from machine learning.
Excellent.
Do you think? Yeah. Do you think it's this is overcome now, or machine learning can give you insight, or what do you think about this?
It depends. When you use a deep learning model, it's quite hard to understand why did you get the specific answer.
Yeah.
So we have many researchers working right now in which we call XAI, explainable artificial intelligence, try to explain why the model delivered that specific value. So it's undergoing research, and many areas, for example, if you go to a bank to get funding, the bank said no. Why no? You need to explain the client. So the society is demanding this kind of explanation of the AI model. I think it's necessary and a trend for the future. We need that.
Yeah, I like it much. This the talk of this guy. Well, let's thank Marcos for his speech. So the last speaker, I know the worst, is Andrea Lombardi. He's an associate professor from the University of Perugia, and it's a pleasure to meet because he's also a friend. So it's your turn.
It's okay.
No, it's not.
It's not working.
Display settings.
Okay.
Okay,
Okay. This is a very it's a short contribution about some molecular dynamic simulation that are oriented to characterize the behavior of this ORF3A channel in the cell membrane in connection with the ionic transport. Okay. So where this ORF3A comes from? It comes from, of course, the COVID virus. Okay. And so the viruses, I'm not an expert in this, but more or less they bring genetic sequences encoding for all the structure of the virus. But some fragments of the information, some strings, do not codify the structure, but some additional proteins that the virus uses to perform tasks, okay, to ensure better replication and better survival of this virus, which is not alive, but for some aspects it is like a living cell. Okay, so this protein in particular, there is a string named ORF3, which encodes the structure of this protein, which is, if you look at the structure, it is suggestive of, in a sense, a vertical development, and there is some space inside, and this is believed to allow the transport of calcium ions through the cell membrane. Okay, so the virus enters the cell, replicates, and these proteins are produced inside the cells, and they penetrate into the cell membrane, creating channels, ionic channels that allow for imbalances, electric imbalances, and which can favor the replication of the virus and that of the cell. In this sense. Okay. So, in detail, the structure of this protein, here there is the membrane, the lipid membrane, and you can see this is quite realistic. Also, the proportions are quite realistic. There is an N-terminal ectodomain, 3 transmembrane domains, which are these alpha helix portion of the structure, and then there is a cytoplasmatic C-terminal domain, which is the part which is most stable in the cytoplasm. Okay, cytoplasm. This is what was the introduction. The reason to study, to pay attention to this molecule, it is that it plays an important role in enhancing and favoring the functioning on the virus, of the virus. Okay, so acting on this, knowing how it works, can help to develop drugs and molecules that can stop the action of this protein and then can prevent the virus to self-replicate efficiently. Okay. Now, the method that I want to use to study this biomolecular system, essentially, it is, of course, molecular dynamics, classical molecular dynamics. This is a huge system in terms of number of atoms and So we need something really practical to run large simulations. Okay. So classical dynamics is the technique, and but even adopting classical dynamics, the ion crossing of the membrane, it is still a rare event. Okay, so you have to reach microsecond time scale, which is a very long time scale in terms of even by classical molecular dynamics, and there is a trick to overcome this obstacle. You can try to add artificially to your simulation box an external electric potential. Okay, not too much, not too weak. Okay, not too strong, because otherwise you can alter the global structure and the physical structure of your simulation of your system, lacking realism. Okay, but not too weak, because it has to be enough to give a little push to your lazy ion to cross the viable pathway through the channel. Okay, so if you do it in the right way, you can observe crossings of ions. Okay, so this is a trick, but it is allowed. Okay. So let me show how to set up the system. This is a large system, so you have to play a little bit in order to put in a reasonable shape your simulation box with periodic boundary conditions, of course. So first of all, you have to retrieve the protein coordinates. This is the easiest task, because this protein, it is already known since a few years now, and it is in the protein data bank. So just the XYZ structure is straightforward. Then you have to clean these files, because usually these are from X-rays experiments and things like that. So they are full of spurious water molecules, and that's it. So you have to clean everything, leaving only the pure protein structure. Okay. Then we need the force field. We use a standard one, char 36M. Okay, which is believed to be enough field for this kind of system. And then we have to generate the bilayer. Okay, so we have the structure, the force field, which can be works with this structure. Then we generate the bilayer, the field bilayer. This can be done using the graphical user interface of CHARM and the lipid database of CHARM. Then you can, in practice, using these tools, generate the 3D structure of the bilayer. Then you have to place the protein inside using some tools which are available from CHARM. And then you can decide the dimensions, the right dimension of the simulation box, E8, Z dimension, and X and Y. Depends on the choice of lipids and on the size of the protein. Okay. And then you have to embed this protein inside this membrane. You have to fill the space inside by water molecules. Okay. And then, in order to reproduce the electric balance, you have to add ions. Okay, potassium and chloride and so on. This can be done using the CHARM CUI automatically almost, but it's tricky. Okay, and then this is your starting point. After that, you have to put life inside your simulations. Okay, because this is not in equilibrium, it is out of equilibrium, so you have to, it is at 0 Kelvin theoretically, because it is a frozen structure. So you have to give some energy to this simulation box and look what happens. And And to do that, you need a molecular dynamics protocol to follow, okay? So the first step is usually the minimization of the potential energy, because you are taking a structure that has been measured for the protein experimentally, okay? Then you put this structure inside a force field. The structure is never the minimum energy configuration using your force field, okay? So you have to minimize, okay, this structure using, for example, conjugate gradients. After a number of steps of calculation, you can hopefully reach your more or less your minimum energy configuration. Then you have to heat, because we need data at 300 Kelvin, okay, room temperature. And this can be done setting simulation in a MVT ensemble, limiting the canonical ensemble, and in various steps, okay, just heating step by step from 0 to 100, then 100 to 200, then 200, 303,15 Kelvin. And this is done, of course, in NVT, so we have to control the temperature, because classical trajectories naturally are constant energy, not constant temperature. Temperature fluctuates, okay? But we need constant T. And this can be done using this Langevin thermostat, which simulates an external thermal bath, in a sense. Okay? And it is standard because it is implemented in many molecular dynamics softwares. So it is not a real problem to that. And these are the first steps. So we have the system minimized, more or less, and at 300 Kelvin. Okay. Now we have to make equilibration of the system, because the system has to arrange the minimum, the best structure, the equilibrium structure, which means kinetic energy distribution and so on, according to this 300 Kelvin temperature, okay, which is not yet done, okay. So we need the equilibration process for some, for a number of time steps adequate. You can monitor the equilibration when the temperature, the average kinetic energy doesn't, is constant, more or less, okay. After that, you are ready to run actual simulations, production run from which you can extract data to study your system, okay? So in this case, we want to observe, these are some additional details, you don't need it. The software is NAMS, okay? And let me show some results. So in practice, the production runs are of two types. One without external field, okay, and a second batch with an external electric field of 1.5 volts, okay, to push out, okay. So with this run, you can observe the properties of the system at equilibrium, which also is important. And in this batch, you can observe the parameters. Okay, this is a scheme of our simulation structure, and this is the zero of the crossing coordinate, which is the z coordinate, because the crossing takes place in this direction. And these are some results. I don't know if it is clear from far, but these points, these dots are ions. Okay, each ion has more or less with different colors. But here we are plotting the sodium ions. Here potassium and here calcium. And when you see these crossings, it means that during the simulation you observe an ion passage. Okay. So first, the results are not in agreement with the original hypothesis so far, because the hypothesis is that this channelity is sufficient for calcium transportation, but instead calcium is the ion that crosses just 8 times against 17 for sodium and 28 for potassium. Okay, so this is an apparent contradiction with the original idea, but we do not desperate because these are indeed the preliminary simulations, and we know that we need much more longer simulations and best potentials, for example. Okay, but there is an indication which is encouraging because we have a few crossings for calcium, but the crossing events are more restricted and concentrated in terms of spatial distribution. You can see here in this figure that, for example, around z equal 10 angstrom, there is a kind of especially from 35 to 40 nanoseconds, there is a kind of very deep concentration around 10 here, okay, essentially, which indicates that there can be a strong interaction of the ion with some protein residues, okay? And in fact, we wanted to make another study, other simulation to observe, to study the interaction with negatively and positively charged amino acids in the structure of the molecule, which are glutamic acid, aspartic acid, negatively charged residues, and lysine and arginine residues, okay, which are positively charged, okay. So these are the targets for calcium. Calcium has 2 charges, so it's 2 plus. It is quite simple to imagine that it should interact with these residues strongly than potassium and sodium. Okay, and indeed, if we look at the coordination number, okay, for glutamic acid and
Excuse me, could you please finish the presentation as soon as possible? Because your time is over and we have other session, next session that will be
okay,
started.
so I have to keep my presentation, but it is just because I'm the last one, but other people before me was late. Okay,
Yeah, we started
sorry.
late.
Okay.
We started late.
Okay, so I try to conclude. So the conclusion is that even if crossings are less frequent, apparently for calcium, we have indication that this ions is quite strongly coordinated by negatively charged residues, which is an indication that in order to understand there is the only this phenomenon of crossing, we have to consider different aspects. One is, of course, just the pathway that is observable when you apply an external field, but you have to take into account also coordination and various aspects. So it is a complex problem, and we are only at the beginning. And so we have to further improve our simulation box and our model in order to obtain the right results. Okay, so I stop here, finish here, and thank you for your attention. And
Thank you.
and,
Thank you, Andrea, for your
sorry,
nice talk.
Don't let me do.
And I think we don't have time for questions.
Sí, pero no hemos empezado tarde.
Sí,
Porque no estaba él.
Pensé que había una presentación.
¿Eh?
Yo pensé que tuviéramos una presentación grande de tiempo.
stop sharing. Quindi lo lascio collegato. Senti,
Pronto?
Good morning. Good evening. Can you hear me?
Yeah. Do you hear us?
Stavo cercando. Yes, we can hear you.
Okay, good. So you can say us when we can start.
Yes, you can start.
Ok. Professoressa, può andare.
The microphone.
Non si sente.
Okay. Good morning. Thanks to all for enjoying the workshop Trece, from structural to transformative change of city environment, challenges and solution and perspective, coordinated by Francesco Sicariani. 5 papers were submitted for the workshop and will streamed for discussion. Based on initial explanation for the workshop piece, they presented a comparing interpretation of the urban transformation from private and public perspective. So we can start with the first contribution by Enzemilla Cavallaro of University of Salerno. She presented a paper titled Sustainable Finance Disclosure Regulation as a Tool for Change of City Environment. Enzemilla.
Yes, I'm trying to share the presentation.
Thank you.
One moment. We see my presentation?
Yes,
Okay.
thank you.
This work is have the scope to underline as sustainable finance disclosure regulations can be a good tool to change of city environment. In particular, this work aims to analyze from a theoretical conceptual point of view ESG criteria, underlying the interconnection with the non-financial disclosure system, and in particular the expansion of set of information to be reported established by the new CSRD, Corporate Sustainability Reporting Directive, with the new introduction of ESRS, European Sustainability Reporting Standards. The diffusion of ESG criteria has involved every economic sector, requiring organizations to take approach promoted by numerous initiatives developed at European and international level, such as the European Green Deal, the Paris Agreement on the Climate, and the Sustainable Development Goals of Agenda 2030. In this context, the phenomenon of sustainability reporting has seen companies introduce information relating to social and environmental impacts. Going beyond the traditional corporate reporting models becomes an opportunity to highlight the interdependence between economic, financial, and socio-environmental and governance performance to create current and future value. The introduction of CSRD changes the reporting of corporate social responsibility, which organizations are called. The directive was adopted on 21 April 2021 by European Commission and introduced changes compared to the previous directive on NFRD. Here, some new characteristics introduced by CSRD. Sustainability reporting that focus on the need for companies to communicate information relating to sustainability, social and governance aspects, improve the transparency of the information provided by companies on their impact on sustainability, applies to big companies with specific criteria for determining which companies are subject to reporting obligations. The scope is changed because it extends to more companies, including big unlisted companies. Definition of more detailed standards for sustainability reporting designed to ensure greater consistency and comparability of reporting and audit requirements to extend the sustainability disclosure to external audit. The most important innovation introduced by CSRD is new standards of sustainability as the ESRS. The adoption of a performance measurement of ESG dimensions with the use of these new standards, ESRS, the attention to sustainable development issues as a reversal of the growth process may represent actions to mitigate the impact on human activities on the climate and environment. Here an overview of ESRS standards. In particular, the new sustainability standards include two cross-cutting standards which apply across all reporting domains and include general disclosure and general requirements, and 10 topical standard relevant information requirements for 3 ESG criteria that includes 5 environmental standards: climate change, pollution, water and marine sources, biodiversity and ecosystems, resource use and circular economy. For social standards on workforce, workers in value chain, affected communities, and consumers and users, and one governance standard, business conduct. Under definition are sector-specific standards that disclosure requirements applicable according to various sectors, and specific standards for SME and assurance standards. With the adoption of ESRS, Europe is taking a leap in standardizing sustainability reporting. This development promises to improve the quality of reporting, providing investors and stakeholders with comparable data. And also employers' companies to clearly communicate their sustainability journey. Organizations need to recognize the opportunity that sustainability represents for innovation and to create long-term value, because the CSRD and the ESRS can have a meaningful impact. Here are some actions that company can make to align with the CSRD and the ESRS. Understand the ESRS requirements. That means understand the information required by standards and how these affect business. Perform a double materiality analysis to identify which topics are relevant in terms of social and environmental impacts, as well as the financial results of the company. Gap analysis to underline the differences between the current data and those required by SRS, and develop an action plan indicating how to address information gaps. Data management and information systems, that means ensure that have adequate system to collect, store and manage the data need to comply with the SRS. Implement processes to ensure the accuracy and the consistency of information. Integrate ESRS requirements into organizations' sustainability strategy and operation, and it's very important to develop sustainability reporting in accordance with the SRS, including quantitative and qualitative information are required, and implement audit processes from independent third parties. Training is very important to train resources on ESRS and sustainability, including staff, executives, and all sustainability employees at all levels. Implement a continuous review process to monitor ESRS compliance and make improvements in the event of a change in standards or business strategies. And the communication and involvement of stakeholders, that means dialogue with stakeholders on sustainability approach and progress. This approach that I just described will involve all the business processes. For the correct implementation of the sustainability framework, a key role is played by the top management and the governance of the company that must have adequate skills, strategic clarity, and make effective and measurable commitments. The future objective is not only related to the harmonization of reporting processes and guarantee a disclosure system that provides clear and transparent information, but in particular the regularization of the value of sustainability reporting, such as financial reporting, with awareness of the relevance of environmental, social, and governance issues. Thanks for your attention.
Thanks. Good. This work has analyzed from a theoretical conceptual point of view the SRG criteria underlining the interconnection with the new non-financial disclosure system. So there are some questions for the discussion.
So I have a question, if possible. So thanks for your sharing. It's really interesting, your contribution. And so I would like is if you during your work have individualized and so have some indicators for expressing the ESRS standards. So if there are some indicators that the reports sharing for using or not.
Not, but the future of this research is to analyze the differences between GRI standards and ESRS, to understand the differences and the point, the common point.
Okay, thank you.
There are other questions? No? So we can pass to the next presentation titled Sustainable Initiative of Industrial Archaeology Conservation and Reuse, the case study of the sample storage in Rome, presented by Lucia Cerra, Gian Domenico Simeone, Francesca Tuba, Maria Rita Turco by Sapienza University of Rome. Thanks.
Okay. Can you hear me?
Yeah.
Yeah, perfect. All right. Hello to everyone. I'm Gian Domenico, and I'm here with my three colleagues, Lucia, Francesca, and Maria Rita. We're going to present our work about the conservation and adaptive reuse of the urban industrial archaeology in Italy. In particular, we're going to show a study case situated in our city, Rome. Okay. The aim of this work is the economical and financial evaluation and restoration project of the former San Paolo storage, an example of industrial archaeology in Rome. The term industrial archaeology denotes a disciplinary approach to studying old industrial sites in relation to their impact to the territory in view of the possible preservation of the building. Industrial sites often consist of buildings lacking on particular aesthetic qualities. In fact, they are designed to meet production needs, so they rarely go under historical artistic protection in Italy. There are a lot of benefits on investing in industrial archaeology, such the high number of new jobs, the less ground use, and the possibility of a more sustainable restoration of the building. Also, the void left by the decommissioning of the factories are frequently situated in strategic location in cities. So the areas could become attractive for economical stakeholders involved in transformation, including the local administration. However, repurposing those buildings, once designated for specific production, present challenging issues, ranging from the land pollution to the high management costs due to the size of these buildings.
The study aims to demonstrate the economic feasibility of the interventions on industrial archaeology. The industrial site can become a strategic node for the community by aligning the project's intention with the needs of the locals. The study regards San Paul Depot. It was built in 1928 under the name of Littorio Depot to house the very first tram vehicles that reached the Basilica of San Paul. The building is located in Rome, specifically in the Ostiense district. The area around the depot has a high density of population, mainly composed of families with children. As we can see in the figure, there are several facilities and services, such as schools, university, and also sports centers, and several bus stops, and one metro station as public transportation. So we can say that there is a potential for the site. The building dates to 1928, but the use of it as a tram depot has rapidly fallen off. In fact, since the 70s, it had been used as a bus yard until its closure in 2000. Since then, several suggestions for reuse have been proposed, but none of them have been made, so the depot remained abandoned till now. Alessandro Severo Street was built in the 50s at a higher level than the entrance of the depot, and so the level of the building is lower than the level of the street. The structure is made of reinforced concrete, and the roof consists of 4 large barrel vaults that are supported on pillars. Surely, restoration and maintenance of the building as a necessary part of the intervention, because the state of conservation is not appropriate. The situation is in fact degrading and abandoned, like for many other industrial architectures, despite their potential.
To better analyze the main feature, it has been used the SWOT analysis, a matrix that is a strategic planning tool used to assess the strengths, weaknesses, opportunities, and threats of a project. The analysis can focus on the internal environment or the external environment. The SWOT analysis identifies possibility and risk within the environment in which the intervention of our investigation is placed. In addition, the project's strengths and weaknesses have been discussed. As seen in the figure, the project area has many strength points like a key position, a high presence of public green areas and attraction, and a considerable architectural value of the building. The area doesn't lack of weaknesses point, for example, the lack of parking areas, the condition of neglected and public green areas, the poor maintenance of the sidewalk, and the position of the storage compared to the surrounding buildings. That this means poor visibility of the structure. However, the area offers a lot of favorable opportunities, such as the high presence of attraction for the students who frequent the neighborhood, the high number of public transportation, and the presence of hospitals and clinics. Even the building itself offers a volumetrical and structural potential due to its nature. Possible threats for a local project are the strict legislative limits given by the local plan, in terms of public service and by the architectural constraints of cultural interest. Also, the fact that the building is highly degraded and the absence of natural light inside the building represents a not easy problem to solve.
In addition to the previous analysis, a survey was performed to assess the project proposal by potential user of the spaces. The questionnaire received 31 replies, with around 55% coming from those aged to 19 to 25 years old. The survey intended to better understand the neighborhood lacking service in order to suggest a concept that would meet the requirement of both residents and visitors. According to the survey, cultural activities, green spaces, and study spaces were the ones valued the most. This finding is consistent with the social and urban study that was made earlier. Based on the results, an initial market investigation on the willingness to pay for the proposed service was conducted. The data obtained indicate that 45% of the public would be willing to pay between 5 and 10 euros for the use of the service. The third and final part of the surveys is dedicated to understand the macro terms that could be pressed in the project and concern to the common interest issues. The overall survey resorts to point to crime reduction, increase of the young population, the greater attractiveness of the area, and the improvements of the public green spaces.
To determine the market value of the project offices, we conducted a direct market assessment. The theoretical idea of production costs, that is the total of all the expenses a developer must incur for a production cycle to continue, is applied to the building costs. To ensure a more comprehensive assessment, the building costs are determined using a metric calculation that is generated using a software employing the unit price of the Lazio region's price list as a point of reference for the works cost estimation. It is projected that the cost of uncommon maintenance will account to 50 to 20% of the building costs, while the cost of routine maintenance would account for 5 to 10%. The total annual cost is obtained from the sum of the construction costs for the first 3 years, fixed costs, management costs, and costs for routine and extraordinary maintenance. Both fixed and operating costs were estimated based on the assumption of use and capacity of the structure. The estimated costs were 35% in the fourth year, 50% in the sixth year, 70% in the eighth year, and nearly 100% from the 10 years onward. By analyzing the costs and revenues mentioned above, we can determine that the cash flow obtained from the project, which allows us to calculate the net present value of the project and the internal rate of return. And as you can see at the presentation, the net present value and the internal rate of return has given good results. And in conclusion of the presentation, this is a master plan of the project proposal that meets the needs of the user that are obtained from the survey, combined to the financial analysis. The goal of the study is to give an objective assessment of the viability of the intervention under consideration, that is, their potential to favorability integrate into the reference environment and attract a large number of users, in particular students and young people. That purpose is intended to offer economical and social benefits to a hypothetical private investor. Furthermore, using the net present value and internal rate of return as a financial sustainability criteria, it may be concluded that the project is economically viable. Thank you for the attention.
Thank you.
Thank you.
Thank you.
È chiuso il microfono, professoressa.
Thank you, excuse me. Well, this paper has presented the economic financial evaluation of restoration and functionalization project on the former of San Paolo storage as example of reuse of industrial archaeology in Rome. I have a question. Why you have not considered or have considered the maintenance of the building in the financial cost?
Matter of fact, we considered the maintenance cost of the building inside. Was the last 2 or 3 slides. The maintenance costs were included in the restoration costs, and then for each year we choose a little amount of money for the maintenance of the building, coming from the activities inside the project. So, in matter of fact, we provide the maintenance of the building. Yes.
The maintenance will account for 15 to 20% of the building cost.
Okay. Because in the table there is not.
Yeah. So, if it's possible, I can add something on this presentation that I really appreciate, and so I really happy for your listening. So thanks so much for your interesting contribution. In general, so I just ask a curiosity for the ongoing work on this research. So what do you think about it? How it could be improved in the next step of your research?
Who wants to speak? I have to. Yes, for sure the work could be improved. Maybe trying to use a big study case, or maybe try to understand if just nothing wrong, but in Italy, this type of intervention or industrial restoration could be sustainable and adaptable for the stakeholders, for the economic stakeholders. Maybe for some, maybe not for others, but could be an interesting study case for the future.
Okay. Thank you so much.
Thank you, Professor.
Thank you.
Thank you. Now we can go to the third presentation that is titled "Financialization of Real Estate Market in Spain," and was presented by Alejandro Segura from Politecnica Universidad de Madrid.
Hello, do you hear me? Can you see the screen? Yes.
Yes.
Okay. Hello, I'm Alejandro Segura, and I have been working with Rafael Eugenio González Díaz in this.
Sorry, Alejandro, sorry. Can you share in full screen?
It's not sure.
So I see the layout.
Full screen, yes.
PowerPoint.
Yeah. Now should be better. No. 1 second. Finestra. Questo. Now?
Now it's better. It's right.
Okay. Perfect. I'm going to present the work financialization of the real estate market in Spain in this session. And first of all, I want to share with you this image. It's from a book from Thomas Piketty, and we can see here that 40% of the wealth of United States of America is real estate. But not just in the United States. If you go to France, to UK, or to Germany, you go to numbers between 50-60% of the wealth of those countries are real estate, are houses, are different kinds of real estate. So when we see the situation from 40% to 60% of the wealth of the advanced economies and 2/3 of the wealth of all the economies in the world are related to the real estate. So if we make any change, if we modify the situation in which the market works, it might lead to a change of all the dynamics of the market and the distribution of the tenure. Here we can see that we are in a world with a very fast development, and we can see here in the center blockchain, crypto, and assets company rates, so things in Spain, and we can see how from the left we can see what has been happening during all the time, and where are we moving in the right side, the innovation dynamics we are having in this world now. And from this point of view, all those elements, the blockchain, the crypto assets, and the assets companies are modifying practically all the issues, all the dynamics of the market. And that's important because we have been seeing that we are moving from the left side, from your property. You are living in a house of your own. The house is yours, and you want to live is what you have in Italy, we have in Spain, and in many countries in Europe is the same. Maybe you can see Germany that more or less 50% of the people live in rental houses, and the other part 50% live in their own houses. But the market is moving for a property distributed property. So the property belongs to a company or belongs to different people, maybe because of the assets company or from tokens from the blockchain or whatever. And the people what are going to have is like they have to pay the rentals in their living place, and they have their income not just from the work but also from the rents and dividends, instead of having their own house, because they have different kind of investments, not just in stocks, in general stocks like you can have buying a company, assets of a company, but also from stocks of real estate houses or tokens from real estate houses. And the situation makes also a modification of the modifies also the market, because we move here from the property care, from the actual situation where you have your house and you take care of your house, to a market where the property management of the rental houses is getting higher and higher. Okay, from that point of view, I have been talking about in this introduction about what we have belonging to tokens, to the part of technology, and also we have the part of the government, of the regulation. And I'm going to talk just about the regulation part. And this is the history of the regulation part of the rates, the real estate investment trusts from the 61, when the regulation was developed in the United States of America, until now that we have this regulation in mostly all of the advanced countries and many others. Most of our countries that we have in this room, we are from Italy, from Spain, from different countries in Europe. So most of the regulations have been developed in the first decade of the 21st century, but with a different development of the countries, because in Italy the implementation of this kind of regulation didn't have the deep impact that has in other countries like we have here in Spain. This point of view is just what's a rate. I think you all know about this. And this is the situation of the market, the development of the market in the United States. I want just to see the right side. This is from the 71 at the beginning of the rates in the United States. But if you go from the point we have in 2010, the rates had a capitalization of 2.6% of the PIB from the United States, and was 0.5% of all the capital stock in the United States of America. In just 10 years, these amounts double. So the rates now account, or in 2020, accounted more than 1.2% of the total capital stock in the United States. This is important because we can see here an increasing market that response is behind what I'm talking about, more property on hands of the companies. And from that general point, I want to talk about the situation here in Spain, what we have been doing. First of all, we have been analyzing all the companies related to rates in Spain. We have 5 in the Spanish Stock Exchange. We have 78 in the Bolsas and Mercados Españoles Growth, BMA Growth, and 13 in the Euronext Access. We have here in this image the first 20, and they are ordered by capitalization. So you can see the 2 first, Merlin and Colonial, are pretty huge companies, are in the IBEX 35, the stock index in Spain, and all the others are in different indexes. We have used the annual reports of those companies, the data from the CNMV, that is part of the regulation in Spain, the indexes from different sources, the data from the company's websites, and also the data from associations related to Narrate, for example, related to those markets. And we have obtained all the documents, first of all by downloaded the documentation, but also doing web scraping. For example, we have here all the houses from different companies that and how they locate those houses in Spain. Okay, from that point, the results of our analysis. First of all, financial results. I have here 8 different companies, and I want to share with you the numbers in orange. First of all, from the revenue real estate investments, we are moving from more or less 3% of the they have a 3% income from all the real estate investment they have. It's a not high number, but we are talking about real estate, so it's normal that this profitability is lower than other markets. But the main point, and the one I'm going to talk about in the following slides, is about those numbers between income and asset valuation changes. For us, has been really important that you can see the income. The income is the result of what the company does, and you have downside the income. You have the modification of the value of the houses they have in their investments, and in the right side you can see that, for example, for Fidere, the changes in the asset valuation has been 2 times higher than the income. If you go to the situation of Cast in 2020, you see that the changes in valuation in that year was the same, close to the same, but in opposite side, minus 45 million. As of the income, you have 55 million euros. So the important thing here is that we are in Spain introducing the result of the modification of the price of the real estate asset is in the year result of the company, and that's important because what we are having is that those companies are having as much as much profit from the changes in the asset value that is not connected directly connected with what they have been doing in the market to rent spaces. That is more or less the same what they have from the change in value as what they have from their normal income of their business. And here you have the different companies I have talked in the previous slide. Also the average of the market. Just in 2020, because of the COVID was different, but we have more or less 0.7, 0.8% of what they are having in normal income. And this is not also one of the biggest issues we are having with these changes in the regulation in the market, because we have also that we include the volatility of the stock market that we have in all the stocks of the Bolsa. The same volatility, we are translated this volatility to the real estate market. We can see, for example, here the orange line, we are moving from 1.20 to 0.70 in 1 year, more than 40% devaluation of the assets of the company. But if you go to the assets of the company in this period, you can see here that you are moving from in 1 year a 10% increase in those assets. So in the value of those assets. So the situation here is that you are including the volatility of the real and of the market, of the stock market and the normal stock market volatility. You are introducing this in the real estate market because you have all those real estate assets as the main investments of those companies. And as conclusions, first of all, we are moving from build to buy market, or build to sell and buy to sell market, to a build to rent and buy to rent. So the focus is to rent the houses. You are not going to have your own house. You are going to rent the house, and then you can move, and you will be connected with the general situation of the market, of the economic. Then that in the second point, the good point of those kind of companies is that they bring dynamism to the sector, but it affects and deeply in the housing prices, and this is connected with what the governments are doing, that they are trying to protect the housing, to make all the people have the possibility to have the house, but at the same time they are regulating in the opposite side. So they are increasing the prices, allowing this kind of, not allowing because they are allowed, but modifying the tax regulation of this kind of investments. And the third point is that the conclusions of what I have been talking in the last slides, this increases the volatility of the market and modifies the asset valuation. So includes one from the property, the normal one, the real estate normal one, and the one of the valuation of the portfolio of the companies. And that's all for my side of my side. If you have any question, I'm open to respond. Thank you.
Good, thank you. This work has analyzed the impact of real estate investment trust in Spain, studying its financial results from the point of view of volatility of the sector and the generation of results. There are some questions for the discussion.
I have just a curiosity for your work. Specifically concerned the next step of your research. So if you thought to do a comparing analysis between Spain, condition of Spain with other countries in Europe. So the other question is if this methodology it could be applied also, or some evidences according to you could be read in other European contexts or not.
Yes, thank you, Francesco, for the question. Yes, of course, it can be developed in any countries in Europe because all those companies are open. The data is open. You can access the data easily, but there is a large amount of data, and the difficult point is how to merge all this data. And the other point is that for me, this is connected with a global situation because all the developed economies have introduced this kind of regulations. And the point is that maybe they are not being used as much now in some countries, but they can be used in the future. So the objective or what the aim of the work is to explain and to make the public sector know that their decision to modify the profitability of the market make changes in the market, and these changes lead to a more difficult possibility for the people to buy a house because this modifier at the end increases the capitalization of the housing market.
Okay, thanks so much.
Thank you.
There are some other questions? No? We can go to the next presentation, titled Remodeling Public Real Estate Asset in Sustainable Perspective, with line from international best practice, presented by Emma Sabatelli from Sapienza University of Rome. Thanks.
Good morning. Can you screen?
Yes.
Okay. Good morning. I am Emma Sabatelli, a PhD student from Sapienza University of Rome, and today I will present this work entitled Renewing Public Real Estate Asset in Sustainable Perspective, Guidelines on International Best Practices, conducted with Professors Maria Rosaria Guarini, Francesco Sica, Francesco Tajani, Deborah Negri, and Giuseppe Ranieri. The presentation is organized into 5 sections. It begins with a description of the framework that forms the basis of the research, followed by the definition of the aim of the work. Next, the application of the proposed methodology is shown, and finally, the results are discussed and conclusions presented. This is best in the context of the urban sustainability assessment. Regeneration has been emphasized in models of urban transformation to reduce negative impacts of urbanization. As a result, the establishment of co-creative multidimensional frameworks is essential for sustainable development assessment practices. These frameworks are widely included in international policies and agendas, highlighting the importance of sustainability analysis in regeneration strategies. The complexity of urban sustainability requires an holistic assessment approach that considers the interrelated economic, social, and environmental dimensions of urban development. In this context, indicator-based assessment systems are widely used by scientific communities, governments, and policymakers to evaluate the success of sustainable development policies and actions because of their ability to reduce the complexity of sustainability assessment. However, the wide range of available indicators, both quantitative and qualitative, addresses different issues at different spatial scales. A major challenge in selecting indicators for sustainability assessment is the interconnected nature of environmental, social, and economic issues. These interconnections makes it difficult to isolate and measure individual indicators effectively, complicating the selection process and also influences indicator selection. In fact, various tools and frameworks are available at different geographic scales, ranging from individual buildings to national and supranational levels, including neighborhood and city scales, each providing scale-specific results. Data availability is another significant challenge. The quality and quantity of data differs wildly across different spatial scales. So larger scales tend to have more complete data, while smaller scales often have gaps. This disparity can hinder comprehensive sustainability assessments and lead to biased results favoring areas with more data. Temporal limitation of data also pose challenges. In fact, many datasets cover only specific periods, limiting the ability to analyze long-term trends and assess sustainable performance over extended periods. These biases can significantly impact the robustness and the accuracy of sustainability assessment. So while sustainability is often more measurable at larger scale, the resulting insights can be overly general, failing to capture the complexities of more localized contexts. In fact, applying large-scale assessment approaches to smaller areas is challenging due to their unique issues and needs. The wide variety of existing indicators used across different scales adds to this complexity, complicating the study of urban sustainability. In this context, the research questions are: what are the main indicators used for assessing the sustainability level at different urban scales, and how can sustainability assessment be conducted through the adoption of upscale methods? To address these questions, this work provides an overview of key sustainability indicators used at various urban scales, focusing on economic, financial, environmental, and sociocultural analysis categories. To this end, a dual approach is taken, integrating bottom-up and top-down strategies. These approaches differ in their analytical orientation. In fact, the bottom-up approach focuses on specific elements to fully understand the topic. By examining qualitative factors from a micro perspective, it identifies the key aspects that best describe the phenomenon. This method progressively identifies the components, improving understanding of each part's function and its integration into the larger system. In this work, it is used to examine a pilot case representative of a larger global context. On the other hand, the top-down approach starts with a broad overview and then focuses on specific details. It begins by defining the big picture and identifying components from a macro perspective, then explores how these pieces related to the whole. In this work, it is a systematic review of scientific articles focused on the application of indicators for sustainable accounting in urban environment. So to implement the bottom-up approach, the redevelopment project of the public housing district of Les Lignons was used as a pilot case. Les Lignons, built between 1964 and 1966, is one of the most monumental public housing districts in the world, with an area of 28 hectares and only 8% of it constructed. The complex features 2 towers of 26 and 30 stories and a Y-shaped building spanning 1,065 meters, designed for dual orientation, maximum sunlight, and numerous integrated services. Les Lignons' design included extensive green spaces, preserving the forest heritage along the Rhone. In fact, recognizing its importance, Les Lignons was included in the federal inventory of Swiss settlement to be protected. In addition, in 2009, Canton Geneva adopted a conservation plan for the site, consolidating its status of cultural asset. Between 2008 and 2011, Geneva Canton faced major energy consumption issues. A comprehensive research project was developed to identify and implement holistic solutions, which attracted considerable interest throughout Europe and North America. For these reasons, the redevelopment of Les Lignons was chosen as an example of best practice and used as a pilot case. Implementation of the bottom-up approach began with the review of the pilot case specific document describing conditions before and after the intervention. This document is essential for understanding the distinctive characteristics of the site and the overall regeneration activities. Key sentences within the document have been highlighted and broken down into smaller units for analysis, helping to measure the sustainable performance of the intervention. An extract from the document is shown in the figure, with the key sentences highlighted in yellow to identify potential variables for analysis. Next, the identified variables were categorized. Each variable was assigned a unit of measurement and a type, so numerical or continuous, categorical or nominal, or calculated. Each was also assigned to the appropriate sustainability category. Using the top-down approach, a systematic review of national and international literature was conducted to identify key indicators used to assess sustainability in urban environments in order to compare them with those identified in the bottom-up process. The review began by outlining the key issues related to urban sustainability and defining research questions aligned with the study objectives. Then databases for literature research were identified and usable keywords were selected to find relevant research articles. Then exclusion criteria were applied to ensure only articles directly relevant to the study's objective were kept. Articles without a full set of indicators or not relevant to the top-down approach were excluded. This selection process resulted in a number of scientific studies pertinent to this work. From these identified articles, a series of information data were collected, focusing on indicators as the main objective of the analysis. These included data such as the year of publication, article title, main objective, sustainability categories, and variables or indicator use. For each indicator, details were collected on methodology type, so quantitative or qualitative, unit of measurement, spatial scale, and associated sustainability services or disservices. Regarding the results of the two approaches, in the bottom-up approach, content analysis identifies 130 key sentences, obtaining 130 keywords after extraction. Due to some synonyms, a subset of 101 variables were derived from these. And these indicators were categorized into environmental resilience, economic financial sustainability, and socio-cultural suitability based on the thematic similarities and correlation among keywords. In the top-down approach, the literature review identified over 200 key performance indicators classified into more than 20 categories. An initial comparison of the results from both approaches validates and organizes key indicators for assessing urban sustainability across different scales and categories. A summary chart illustrates the maximum number of indicators included in the performance evaluation system of Lelignan intervention. In total, 81 indicators were identified for environmental resilience, 47 for socio-cultural suitability, and 66 for economic financial sustainability. The figure displays a part of indicators of the set of indicators detailing their measurement units and types, and specifies whether they are sourced from official dataset. Under the environmental resilience category, indicators assess the environmental impact of urban development, such as temperature-related metrics and land use indicators. Indicators in the socio-cultural suitability category assess aspects of urban social and cultural life, including measures of education institution quality, health service availability, and crime rates. And finally, the economic and financial sustainability category evaluates resource management and economic vitality, including indicators of employment rates, housing market conditions, and costs related to water supply and heating, cooling services. So, in conclusion, the proposed methodology addressed the study's main research questions, producing a comprehensive framework of indicators for measuring urban sustainability through comparative analysis. These indicators are adapted to different urban scales, ensuring accurate and contextually relevant assessments. The methodology also demonstrated the effective sustainability assessment through upscale methods, enhancing the adaptability and significance of metrics across various urban levels. So the key features of the methodology include its dual approach, combining top-down and bottom-up techniques for a balanced assessment view. Its adaptability allows for application in diverse contexts, particularly those requiring consensus for decision-making, thus increasing its utility and relevance. And in practical application, the approach proves valuable in critical areas such as ecological restoration, environmental monitoring, land use planning. Future research will focus on a validation phase to verify the general validity of the obtained information. This phase involves the distribution of questionnaires to environmental and social science experts, as well as technicians and operators in the building and real estate sector. And this aims to improve the reliability and the applicability of the results by defining a subset of case-specific indicators in line with stakeholders' interests. Thank you for your attention.
Thank you. Good. This paper has identified a set of key indicators can be used to assess sustainability at various urban scales, focusing on key categories such as economical, financial, environmental, and socio-cultural analysis. So there are some questions.
So I have a question for Emma. Thanks for your sharing. So do you think that this procedure, this method, the results obtained by this methodology is more specific to the type of the project that you have studied, or not? So
Now, the pilot case that we have considered, the Lignon case, is an example because the methodology is adaptable to various contexts and various projects of renovation and requalification.
Okay, thank you. Thank you so much.
There are some other questions? No? Thank you.
Thank you.
We can go to the last paper titled Ecosystem Services Accounting and AECP for Prioritization Landscape Design Strategy in Urban Areas, that is presented by Francesco Siga in substitution of Fatani, who can be stay here with us. Thank you, Francesco.
Thank you. So do you see the screen?
Sì.
Yeah. Okay. Thanks. Thanks for the presentation and introduction of the work. This is by Francesco Sica, Fatane Fatai, Cristiano Imberghini, Maria Rosaria Gorini, Francesco Tajani. It is about, it is concerned the defending of the application of the HGP procedure for accounting and ecosystem services and their mainstreaming in the decision-making processes for a prerequisite or a standard for towards green transition of the urban project in city setting. In particular, the outline of the current presentation is about is as follows: understanding what are the ecosystem services, why they are fundamentally important for supporting support the transition, the green transition in the city. The second section is about the introduction of the HGP procedure. The third is about the criteria for prioritizing the ecosystem services in the urban setting. The last one is about the explanation and the description of a case study site in Rome. So, in general, the ecosystem services are defined and are explained as the main benefits derived by the existing of ecosystems, specifically in the urban setting. In particular, we can individualize some particular and fundamental topic around the meanings of the ecosystem services, likely the biodiversity and ecosystem health, the economic value of ecosystem services, and also the aspects, the cultural and social aspects relating and faces the ecosystem services in its meaning, its intrinsic meaning. According to these three main clusters, there are a lot of methods and tools and approaching for accounting the ecosystem services it depends on the urban and different contexts of application. Quantitative and qualitative assessment, integration within decision-making processes and a model that are defined in general for and within different and diverse decision contexts. And then last but not least, the accounting of the ecosystem services filtered by the point of view of the stakeholder perspective. So which are the value, which are the meanings of the ecosystem services by the point of view of a different stakeholder that can be involved and can be interested in participating and manage within the decision-making processes for a specific project. But why it is important integrating mainstreaming the ecosystem services accounting in the urban context. There are a lot of projects, there are a lot of many diverse decision-making contexts that can be related and concern the urban setting. For example, the ecosystem restoration and conservation, promoting sustainable practice. What is mean to sustainable practices? There are referred to action that are fundamental for supporting development that should be sustainable on a different point of view, economic, social, and environmental. And they are fundamental ecosystem services for building resilient ecosystems. There are a lot of measures at the European level concerning the climate change or otherwise the resilient cities. So integration of the concept of ecosystem services within and across the decision-making processes can be offered the possibility for accounting in the operative terms what is the resilience, how we can evaluate the resilience across and within the urban settings. So the research question and the research objectives and the question underlying the content contribution are specified in terms of evaluating the ecosystem services provided by urban landscapes. So how we can use these instruments, otherwise other terms ecosystem services, for prioritizing landscape design strategies to maximize ecosystem services benefit. Another crucial point with the concern of the ecosystem services is that these concepts, these items can be declined according to different points of view, private and public. So we assumed on the basis that the ecosystem services are more related and are more important for local collectivity. So for this reason, the maximization of the ecosystem services benefit. In terms of a key research question, what are the most valuable ecosystem services in urban area? So which are the criteria for prioritizing the ecosystem services within the urban context, and how we can optimize some specific design strategies than other one for enhance that specific ecosystem services that are calibrated and are more related to urban context, where can be allocate and where there can be site and place the action. So the EHP in particular, it is a hierarchic structure that can be painted that can paint the decision-making structure in general. It is based on the comparison principle, pairwise comparison. It is a fundamental aspect of the EHP, and it offers the possibility to construct to build a mathematical modeling that can be derived by theoretical approaches related to the EHP structure. But how by the screening in the literature, the EHP method can be referred to ecosystem services accounting. In particular, offer the possibility to chance to identify priority area for ecosystem services allocation, incorporating stakeholder preferences and balance multiple criteria. So it is fundamentally important for negotiating the trade-off between different ecosystem services in the production, in the supply and demand of ecosystem services. So it is a suitable approaches for covering all these aspects. But which are the benefits, which are the limitations, the boundaries of the HTTP application ecosystem services priority? The first one, one of the main benefits is the facilitation of transparent decision making. So it could be realized a friendly and readable structure, for example, in Excel file layout, for enhancing the communication between the different stakeholders, for a more transparencies between the different point of view that are involved in the decision-making system. But there are limitations concerning the complexity in data collection and addresses interdependencies. So data collection, This is more related with concern which are the metrics, dominant metrics for accounting the ecosystem services, and how we can manage and rule the interdependence between different ecosystem services. Otherwise, in the optic of prioritization, difference and multiple decisions, but towards the achievement of our main goals. In order to gap and to enhance and to enhance the benefits derived by the application of the HHP with concern to the mainstreaming ecosystem services in urban area, we have focused on the which are the criteria that we can use and assume as reference for prioritizing ecosystem services in a specific urban setting. In general, we can individualize the ecological importance, so biodiversity hotspots and keystone species, ecosystem resilience and adaptability, carbon sequestration and climate regulation. So there are 3 different criteria that characterize the ecological importance, the main criteria as a keystone for the ecosystem services accounting. The second one is about the human well-being, how we can measure and translate in operative terms the benefits derived by the ecosystem services for the collectivity, for the society, provision of food, water, and raw material, cultural recreation value, health, and medicinal benefits. So there are sub-criteria concerning the human well-being, main criteria, main keystone of the ecosystem services accounting. And then we have also socioeconomic consideration, which are the economic value according to the willingness to pay by the livelihoods that surrounding the urban area. Another aspect is concerned the risk reduction and disaster resilience in terms of avoided costs, the live application of a specific project that are important, fundamental for improving the supply of that specific ecosystem services. And the last one aspect is about the equity and the social justice. So the how we can fight the urban gentrification in order to ensure a just right balance between in terms of right allocation of richnesses between different section, different urban parts of the city. So we try to test the application and to test and to trust the application and the adaptability of the HP method for a specific case study that is concerned how that its aims is to assess, to prioritize landscape design strategy in the urban area, in particular in Rome. In particular, specifically, the problem is to how to prioritize landscape design strategies in the context of Rome, enhance urban sustainability and quality of life in city of Rome. And these two goals reflects the needs to balance different type of ecosystem services concerning negotiation of different needs that characterize a general urban area in a complex structure of the city. The study area is surrounding the Valle Giulia faculty, architecture faculty of Rome, and this is located near the Villa Borghese and other iconic representation of the city, likely the British Academy, National Gallery of Modern Art, Academy of Romania, and so on. We defined specific steps that are previously and before the application of the HP. The first one is about the zoning, how we can characterize all the area closer to the Faculty of Architecture in zoning to analyze in terms of supply and demand of ecosystem services. The second step is about the inventory of the ecosystem, which are the pertinent ecosystem concerning that urban area, and then the application and implementation of the HP that is based on the hierarchical structure in terms of identification of goal, criteria and sub-criteria, measurement of indicators, metrics of ecosystem services, and then prioritization of the alternatives. Zoning. We assume some specific physical features for characterizing a subzoning, the implementation of the zoning with the pertaining the urban area of a study, likely the terrain, the soil types, the topology of ecosystems, so also the species diversity, the habitat types, and other some socioeconomic factors, population density, land use patterns. In this perspective, in this way, according to the point of light, we have assumed and individualized 3 main zones: Zone 1, natural zone; Zone 2, urban; and Zone 3, semi-natural. Then we jump to the identification of the main ecosystem services of the study area. So, because the area is characterized a significant influence and flowing of the students that leave the space of the faculty of the architecture. We focus principally on the cultural services, and then we have added other types of services as complementary to this one, supporting, provisioning, and regulating, like, for example, the biodiversity, the genetic resources, the climate regulation, the water sanitary, and so on. For this one, we have individualized some specific qualitative metrics that can be helpful and useful for implementing the HEP method. So then we jump to application and implementation of the HEP in terms of structure, the decision-making processes, in terms of goal, criteria, and sub-criteria. And we just preferred and supporting the using of a equal weight criteria evaluation. So we assumed that in the first step of analysis that all the criteria, all the ecosystem services were weighted equally, and so for implementing a more simply and fastly comparative analysis between each of other. And so we just developed a EHP for the different cluster of ecosystem services, cultural, regulating, supporting, and so on, in order to analyze and so which is the best zone for devoted to the specific ecosystem services. So the comparative analysis was done for each topology of ecosystem services, and so for supporting, for provisioning, and for regulating. First of all, and after this implementation, we can arrive to define some final remarks. For example, the zone 1, it is very close to the faculty architecture. It is more proper and for adaptable to the educational focus, so to the cultural ecosystem services. The second one is enhancing pollination services, that it is front of the faculty of architecture. So it could be proper for establishing pollinator-friendly habitats, promoting organic farming practices, and for supporting the companions' awareness in food production. So, in the conclusion, the application of the HEP could be helpful for systematic prioritization, allocation of informed resources, taking into account the different aspects between them of environmental, social, economic point of view, and it is helpful for evaluation of trade-off between different type of information, social, cultural, economic, and environmental. So on. It is a good strategy for towards the improvement, the engagement of the stakeholder, specifically in the step of the comparison between the alternatives, and it could be helpful for giving us answer as results, specific insights for policy making and planning technicians, and it could be helpful for supporting the implementation of action for towards a sustainable development of the specific context of the city. This is all, and thanks for your attention.
Thank you, Francesco, for your presentation. And if you can explain better how you have speak with the stakeholder that.
Okay. Yeah, we just realized a workshop group, so a group focus group. So this is concerned an exercise by a group of students, a course of study in architectural faculty. So we realized more or less 4 focus group where we show and shared with the students a table where we ask to compare each ecosystem services to another for clustering in order to give some numerical score for expressing the relative importance of each alternatives or each couple of ecosystem services.
Okay, thanks. There are some other questions. Okay, thank you to all for are present in this workshop and for all the papers that are presented that for me are all interesting, and we can close, I think, this workshop.
Okay, thanks to everyone. So see you later. See you soon.
Thank you.
Thank you.
Goodbye.
Bye-bye. Bye.
Bye. Ok, Francesco, ci sentiamo per telefono.
Va bene, d'accordo.
Grazie, ciao.
Ciao.